What is an automobile engine? Its diagram, parts, and how it works. An automobile engine is known as a heat engine or internal combustion engine. It burns fuel to generate heat to produce mechanical energy. For cars and other vehicles, a wide range of propulsion systems are currently or possibly available. The engine is the heart of your car, a complex machine built to convert heat from burning gas into the force that turns the road wheels. In this video, we'll explore what an automobile engine is, its history, its diagram, how it works, its parts, and its types. A quick reminder to subscribe, like, and share this video. What is an automobile engine? An automobile engine is a positive displacement internal combustion engine with an intake, compression, combustion, and exhaust stroke. Its main job is to transform energy from fuel into working power. In other words, it produces the power that makes the car move. The engine is the heart of your car. It is a complex machine built to convert heat from burning gas into the force that turns the road wheels. Different inventions on propulsion systems are widely available for automobiles. These include internal combustion engines fueled by petrol, diesel, propane, or natural gas. Other options are hybrid vehicles, plug-in hybrids, fuel cell vehicles fueled by hydrogen, and all-electric cars. However, fueled vehicles are most beneficial due to their limited range and high-cost batteries. The main purpose of a gasoline automobile engine is to burn gasoline and convert it into motion, which enables the car to move. Aside of electric vehicles, the easiest way to create motion is through internal combustion engine, which means combustion takes place internally. Brief history of an automotive engine. Electric motors and steam engines were put to the test in the early years, but they weren't very successful. The internal combustion IC engine dominated the 20th century. As of 2017, gasoline is the fuel of choice for American cars. Steam and electric engines competed with internal combustion engines in the early 1900s. The idea behind how internal combustion engines operate is that the force of an explosion propels a piston. This explosion is burning the hydrocarbon in the cylinder head of an engine. Only around 1/4 of the automobiles produced at the time were really classified as internal combustion. The internal combustion engine emerged as the most widely used vehicle engine throughout the course of the following few years. Rudolf Diesel developed a brand new type of internal combustion engine at some point in the 19th century, employing the idea of pumping liquid fuel into air heated only by compression. This is the ancestor of the contemporary diesel engine utilized in cars, but more particularly in heavy-duty vehicles like semi-trucks. A quick reminder to subscribe, like, and share this video.
How does an automobile engine work? A spark ignites a mixture of compressed air and gasoline vapor inside a temporarily sealed cylinder, setting off a series of processes that lead to the achievement of that goal. The cylinder then burns quickly. Because of this, the device is known as an internal combustion engine. The mixture expands as it burns, giving the car the power to move. An automotive engine has two primary components: the cylinder block, which is the bottom, heavier element and serves as a housing for the majority of the engine's moving parts, and the cylinder head, which is the higher, detachable cover. The air and fuel mixture enter the cylinders through valve-controlled passageways in the cylinder head, while combustion-related gases are evacuated through other valve-controlled passages. The crankshaft, which resides in the block, converts the piston's reciprocating motion into rotary motion at the crankshaft. Major parts of an automobile engine. The following are the parts that make up an automobile engine. Piston. This is a cylindrical piece of metal that moves up and down inside the cylinder. Valves. The valves open and close at the proper time, so that air and fuel can enter the combustion chamber and compress to let out exhaust. Spark plug. This is what ignites the air-fuel mixture so that combustion can take place. Piston rings. They prevent the fuel, air mixture and exhaust produced from escaping into the sump during compression and combustion. It also prevents the oil in the sump from entering the combustion chamber. Crankshaft. This is what converts the piston's up and down motion into circular motion. Connecting rod. This engine part connects the piston to the crankshaft. It rotates at both ends, enabling its angle to change as the piston moves and the crankshaft rotates. Sump. It holds the oil that lubricates the engine components. A quick reminder to subscribe, like, and share. Types of automobile engine and internal combustion engines. ICEs. For many years, gasoline or diesel-powered traditional ICs have served as the foundation of the automotive industry by providing a balance between performance and efficiency. Their emissions and reliance on fossil fuels raise environmental issues. Electric car engines. Using electricity stored in batteries to power vehicles, electric car engines are at the forefront of sustainable mobility. They are a potential option for reducing the effects of driving on the environment because they offer high efficiency, instant torque, and zero emissions. Hybrid engines. These engines combine electric motors and batteries with internal combustion engines, often gasoline-powered ones, particularly while driving in cities. This hybridization improves fuel economy and lowers pollutants. The intended purpose, necessary fuel efficiency, environmental impact, and technological improvements all have an impact on the choice of car engine type. Electric and hybrid engines are becoming more common as the automotive industry transforms towards sustainability and lower emissions, spurring innovation and transforming the future of transportation. The industry's dedication to addressing both the necessity of environmental responsibility and the changing desires of consumers is shown in the diversity of car engine types. A quick reminder to subscribe, like, and share. Types of automobile engine. By layout. An engine layout means the number of cylinder in an engine and how they are arranged. There are many kinds of engine layout, but three are popularly used in car engine: straight or inline engine layout. The straight or inline engine configuration is the one that is most frequently used. The cylinders are arranged vertically in a line, one behind the other, as the name suggests. Depending on the number of cylinders, these types of car engines can be installed in the car parallel or perpendicular. The engine configuration is classified as straight when it is parallel to the vehicle and as inline when it is perpendicular to the vehicle. Straight inline engines are utilized frequently because of how simple and affordable it is to manufacture and install them. Due to its small size and capacity to fit other automotive components around them, inline engines are often seen in entry-level family vehicles like hatchbacks. On the other side, straight engines can have more cylinders, which results in more power. Straight engines are found under the hoods of luxury vehicles from brands like BMW and Mercedes. Flat engine layout. A flat engine has its cylinders arranged horizontally, unlike a straight engine. Due to the piston action simulating combatants hitting their gloves before a match, it is also known as the boxer engine. The boxer engine is well balanced, and by balance we mean that there are fewer vibrations as a result of the force that the pistons produce as they move. The flat engine's low center of mass is another feature that enhances the car's handling. Due to their enormous surface area, the cylinders are all evenly cooled by air. In comparison to straight engines, flat engines are more expensive to produce, and many vehicle manufacturers do not like their wide design. V-engine layout. A common engine design used in almost all high-performance vehicles is the V-engine. When looking at the engine from the front, the cylinder banks, or the space in which the pistons move, are arranged to resemble a V. The ability to fit more cylinders in a smaller space distinguishes this arrangement from other engine designs, i.e., more power without sacrificing the car's aesthetic appeal. The V-engine is more prone to vibrations than a straight engine, and because of its more complex construction, repairs are more expensive. However, because every piston completes its power stroke in a shorter amount of time, this type of architecture generates greater power. A reminder to subscribe, like, and share. Types of automobile engine. By configuration, the number of cylinders and engine layout determine an engine's power and performance. This has great effect on the fuel efficiency, its sound and power output. However, high-tech fuel injection systems and other efficient engine parts make even smaller engines give higher outputs compared to larger engines. The following are the types of engines by configuration. Twin cylinders. These engine cylinder configurations are rare due to their capacity and low power output. It is found on the Fiat Twin-Air car versions, like the Fiat Panda Oria and Fiat 500 Twin-Air. This is because the turbochargers make use of small, eco-friendly twin-cylinder engines. Three-cylinder engines are mostly found on small cars, but recently started appearing on larger family hatchbacks, like Ford Focus. The engine is known for its distinctive burbling nose and its shuddering vibration. This factor affects the engine bounce. Four-cylinder. The four-cylinder is the most common configuration that exists on the majority of small to mid-range cars. It offers a good amount of engine output, and the introduction of a turbocharger makes it more powerful. The engine is set in an inline layout, 5-cylinder. These engine cylinder configurations are very rare. Just like the 3-cylinder engine, it also suffers vibration, leading to offset and imbalance of the engine, affecting its comfort and refinement. 6-cylinder. 6-cylinder engines are typically configured in either a V or straight layout. Since the inception of the turbocharger, it has become a staple in high-performance and sports vehicles. Historically, it has been established that 6-cylinder engines were not regarded as the pinnacle of power. 8+ cylinders. Engines featuring these cylinder configurations are typically arranged in a V formation, commonly known as V8, V10, and the newly introduced V12. Vehicles equipped with 8 or more cylinders are commonly associated with high-performance supersport models. The V12 stands as the largest engine configuration in use. However, the introduction of the Bugatti Veyron marked the debut of the 16-cylinder layout. A reminder to subscribe, like, and share.